But I don't. Were other people able to hear Stephen when he was talking, or was it just me?
That's just what I made out of it, but I think that's what
Can you hear me better now?
Yes, now I can. Thank you.
I was configured to the wrong microphone.
Okay. Yeah, it sounded like you had like a mouth full of marbles or something. Okay, now we're on the air. Sorry about that. So folks, we just, if you want to watch this, we forgot to start this. The deep dives topics, number 168 is still open. People can add stuff in there. There's an update on the CPU profiling in this issue, issue 178, the issue for this meeting, so people can read the update there. Michael Dawson opened this Diagnostics Channel next steps, so that's issue 180. I think this is everything we sort of talked about from the summit. So it's good to see this thing happening. I will try and alert some folks on my end that should be interested in this in more detail, and hopefully they can get involved, but I wouldn't hold my breath on it. So we'll see how this goes. Does anybody have anything to add on this?
You mean specifically on?
Well, in issue 180, which is just next steps for the Diagnostics Channel stuff that we've been talking about.
Should we wait until Michael Dawson is back in the next meeting to talk about this, or like can we? I mean, there is a next list of next steps.
Yep. No, I mean certainly it's on the agenda for today, and so if anybody has anything to add, now's the chance to add it. I don't think we have necessarily quorum or the right people here to make traction, but I didn't want to close out or starve out conversation because one person was not present. I will say this, that there's overlap with this number 134, which is where we were originally discussing this. So I'm tempted to just close 134 in lieu of 180. If that is, if that's what people think is legit, that's the right thing to do. No opinions on that?
I don't think there's a hurry to close that issue, right?
Yeah, I don't know exactly what, I mean, there's a lot of detail in the discussion, but I don't know that it's the right thing to actually make progress on stuff. It seems a little cluttered, but I don't know what the next action is. I mean, it's like 180, I think, is capturing the next set of actions on that. We'll leave it open for the next time around. The trace event.
Next option would be for somebody to sit down and actually start prototyping stuff. Like create a repo, or even without a repo, just go do stuff.
For one, yeah, but I think the issue is that we've got two issues open. Number 180, which Michael Dawson just opened, which is sort of a summary of what we need to do next. And then this issue 134, which is where we were talking about this for a while, right? And it has some discussion, but it's kind of long, and it's not really clear what the next steps are in 134. So I think 180, my point is 180, I think succinctly captures what it is we need to do next. 134, I think, is there if anybody wants to come in and, read through comments and discussion. But I don't know that 134 has any other action on it. Like, I don't know what the next steps are for 134. Is that clear?
Yeah.
Okay.
Then?
What's that?
I guess we should close it then.
Yeah, I mean, we can, unless somebody thinks I should leave it open until there's more people around to tell me we should close it. I mean,
just close it. You can always reopen it.
Okay, let me do that. All right. So trace event tracking issue number 184. I don't know if there's any update on this. I know I saw a bunch of mails about PRs that James opened about some tracing stuff. I haven't looked at any of that. So
yeah, I can summarize the discussion on those PRs. We opened a PR a little while back on adding a API for JavaScript to enable and disable traces, and trying to figure out how clients should use it. So right now, the mechanism we have right now using the command line options is quite limited, and you cannot have multiple actors enabling or disabling trace events, or specifying anything other than what was enabled at the startup time. So the API would enable some of these, and there's some discussion on whether certain use cases are things we need to support or not. So I think there's a good amount of discussion on that issue. I think it would be good for people to take a look and leave comments if they have any. So certain decisions are being made about whether we should support certain things right now or not. So for example, whether we want to have multiple targets, and the general feeling we have is, no, we're not going to have at this point multiple destinations for the trace file, where different clients could ask for different events only, and we do filtering and route them to the appropriate destination that they've asked for. So we're thinking that we shouldn't support that at this point, and also whether or not we should support exposing the trace buffer to JavaScript so that JavaScript can decide where to send it. That's again also the general consensus on that issue is that that's something that should not be exposed because that would defeat the benefit of trace events, which is intended to be low overhead. So good discussion in there on what kind of API we want. And so please take a look and add comments if anybody has them.
Excellent, thanks. Anything else on this one? Okay, moving on to the async hooks tracking issue number 124. I think the last thing here was Yang had some promise hooks perf stuff that he was going to do, and the last 2 weeks ago he said he didn't have time. I haven't seen anything, but I easily could have missed it. So I don't know if anybody knows what's up here, if anything has happened on it. Sounds like nothing. Is that fair? Okay. Okay, so then number 107, async context formalization diagnostic support, and Kelvin, you opened number 179. And I did some work this morning on some of the stuff that I promised last time that I talk about, and so I can talk about that. Kelvin, I don't know if you want to talk about what you've been doing. You want to share a screen and show some stuff, or how do you guys want to proceed?
I mean, I don't have a library yet, so it's just the screenshot that I have there. It's like terminal output. I realize I don't have a lot to say about it other than that I've been working on it right now. Like, I was planning to hopefully talk about how it depicts, like, you know, linking and causal context, but it doesn't yet. So
okay, let me try and get a screen shared here, and I think that's working. There, you know what? It looks like there's a couple of folks on the YouTube stream, so I don't know if they're asking questions, and I don't know if somebody can maybe watch that, because I haven't been paying attention. But we certainly, if people are asking stuff, ideally we wouldn't miss it. Okay, so
Before you get started, Matteo, have you been doing anything with the like bubble prof?
People are asking stuff. Ideally, we wouldn't.
So we are close to something that can be shared.
You've been doing anything with the.
Literally, it's. I still don't have something on the code, but that can be easily demoed and proved by some other people. I think we can have something in the next couple of weeks' time. It has taken a lot of time to make that UI really usable, apart from some very specific demos that we have been toying with when we showed it last time.
Yeah, because often a big gap between showing the graph and showing it usably. So, I think some of these things are great for understanding the async semantics, but then what you would want to show to a developer is another question. So I think we want that discussion, as a second thing, but I don't want to let it fall to the wayside entirely.
No, it's don't worry. This is something I had to tell to the group. We probably can do a quick demo and show the tool and distribute the tool to all of you. Probably mid-April, the next meeting, like the 18th of April or something like that. If we can schedule like a 10-minute session or something like that, will be very good.
Awesome. Okay, sorry to interrupt you, Mike. I just wanted to grab that.
Yeah, that's all good. So, so I haven't had a whole lot of time to work on this, but I'll try and give folks some idea of what I've been trying to do, and I think maybe some of the interesting results. And I'll qualify this right now by saying it's still kind of half-baked, but I'm open to feedback. So in this async context definition repo, there is a branch called mkaufman add monkey patch tracking, and that's what we're looking at now. And I'll sort of quickly walk you through the code, and then I'll try and focus in on what I think is maybe the interesting piece of this. The intent with this is I wanted something that would sort of produce the model that we've been talking about in sort of a automatic way, right? And so there's some code that we had through a couple of different sources. Mark had an intern a couple years back, and he went through and identified all of these sort of asynchronous continuation points inside of Node and captured them in this funky file. So then we know all the functions that somebody can pass a function, all the functions that you can pass a callback to, and then we can wrap those up so that we can generate the right events. And so we do that dynamically. And that's in this async track file. It's all TypeScript, so hopefully it's not too crazy. But like I said, some of this is a little, still needs some cleanup. There's this async context events, which is just raising the events that we've been talking about, right? And so there's sort of or TypeScript definitions for the different event types that we talked about, begin, execute, and execute, link, and cause, right? And the various IDs that we've been talking about. And then some methods to raise those events and a method to add a listener to those things, right? So that's fairly straightforward. I think we have an execute context stack, which allows for sort of, user space queuing. So it's not just one current context, but there's a stack of these things, right? And then there's this continuation file. And so this, I think, is the interesting thing. And, Mark, feel free to jump in here, or feel free to, chime in if you think any of this is off the mark, or if you disagree with any of this. I think the interesting piece here is this notion of a continuation, which is basically a function that you're going to pass from one execution context through some API that is going to get executed asynchronously in some other context, right? So, and I think this helps sort of two things. I think one is it helps formalize some of the terminology that we've been talking about. We've been talking about like link and cause events and what do these things mean, right? But I don't know that that necessarily relates to user code. And so I think this is maybe the next step in firming up the terminology that we've been using. So there's this notion of a continuation. It's expressed here in a TypeScript interface, right? And it's basically just a function, and it just has some marker thing that says, yes, this thing is a continuation. It's got the original function, the thing that it's wrapping, and then it's got the IDs associated with it when those things materialize, right? And then there's this, these two methods here, link and cause, right? And this is effectively the API that a host would use to, implement this model, right? And that's what we use in that async track. Anywhere we go in and we monkey patch these places that we say are these, continuation points, we'll actually take the function that was passed in and we'll call link on it. When you look here, link has this stuff that says, oh, well, if the thing that we were passed is a continuation, and just continue on. Otherwise, we're going to go through some logic here that's going to continuify it effectively, right? And that is we'll basically wrap up the function that was passed in so that when it gets executed, we'll raise the before execute, we'll raise the after execute when it's done, and we'll set up the appropriate IDs, right? The cause is fairly simple. So the interesting thing about this is kind of the API that you would want for any host, right? So if you wanted to implement some of this stuff in native code, I think you would end up with a very similar API. And that's actually something that we've been, I don't want to say that we're working on, but it's something that we've been talking about internally. That is, what would a native API for this look like? And then how is that going to get leveraged in some different contexts that we might do? To see what some of this looks like, so it's a bit of, I think, to Mark's point previously, the graph gets bigger, right, than what we were looking at, sort of like this idealized notion, right? There's significantly more events because we're instrumenting a lot more of Node's API surface, right? So for example, when you call console.write, that ends up, calling into a stream that is an asynchronous continuation point that gets flushed later. That stuff shows up in this graph. I won't step through the whole graph. I don't think, like I said, it's half-baked. I don't have a really good way to associate the line numbers in the code with what it is we're looking at in the graph yet. So that still needs to get worked out, and I don't have the output stuff wired up yet so that shows on this graph. And this gets a little, let me see if I can zoom out. Zoom here, and what's going on? But this is what the graph ends up looking like in this case. So it does seem like it is producing events. The cause events for promises isn't wired up completely. I need to go back and look at that. And I think the other bit here is this is predicated on being able to monkey patch promises at this point. So it's not going to work, I don't think, on more recent versions of Node. That's sort of the quick update here. And I don't know if anybody has any questions or anybody thinks this is crazy or anything at all, let me know.
So this visualization looks like very complex, okay?
Sorry, the visualization does?
Yes.
Yeah, and...
Which is a technical...
Go ahead.
Which is a representation of what's going on under the curtain. On top of this, what you want to Like I don't see, given that this is a very simple script, I don't see this visualization is going to become unfeasible very quickly for a normal user, for a normal application.
Yeah, I mean, I think the intent with this visualization is to, just like I think what Mark was saying earlier, which is to communicate the concepts of what it is, we've been talking about and visualize those, because I think in the small scale, it helps, right? I think the challenge with what we're looking at here, and I haven't had really the time to work on it. I worked on it a little bit this morning and was able to get it this far. But the challenge with what we have here is that there's no way to look at this stuff and then relate it back to the user code, right? And say like, oh yeah, I know that, this execute 8 here is probably this console.log from line 6 in the code, right? And I haven't figured out how to wire that thing up yet, right? But the information should be there, right? But visually, I can't put it in here. But that said, it's like, I don't think this has a life beyond just trying to get everybody on the same page with respect to the concepts that we're talking about and the user model for asynchronous code execution, right? Which is what we're really focused on, right? Is like, well, what is the user model there? And then there's different ways to implement it. One is this monkey patching thing. Another is, you've got, a host, instrumenting stuff, right? Async hooks may be able to do a similar model, right? But I think that's the key thing here. Does that make sense?
Yes, absolutely.
Okay.
Yeah, and as we go on, like there've been a number of academic projects on trying to visualize async execution in, JavaScript, including some with small scale developer studies. So as things get more sophisticated, I'm happy to, share some of that and we can discuss that in more detail. But yeah, as Mike was saying, the key question is, one, just help people understand like what is the base semantics of async execution, and are we capturing what we need to capture? And then the question is, well, then how do you post-process that to make it easy for a developer to understand?
So something that jumps out to me now is that I feel like the tree of nodes visualization doesn't. I mean, one thing that seems lost is like the temporal factor. Like looking at this, I'm not sure. I'd have to look through each of the indices to know what comes first. That would help a lot, especially since right now we don't have links back to line numbers, right? I'd rather see this, a strict rule where an event with a smaller ID occurs higher up on the y-axis or something like that.
Yeah, and the extent, so this is using what I wanted to be able to do here was have sort of step through visualizations. And I think that worked when I coded up, or hand coded what the expected event stream was given, some code, right? And I think that it's been fairly effective, at least internally, as we've been talking about this. We've been able to say like, well, here, let's look at a picture, right? And then everybody's like, oh, okay, I can get on the same page with it. What I don't think this is this isn't anything that scales. This isn't anything you would ship, right? This isn't anything that lets you solve a problem about a real application, right? And so, but I do think that the question then is well, does the event model that we have, right, and the set of events that we have let you present the information in a way that would let users solve real problems? So for example, if you want to know timing information, could you do that? I think the answer is yes. I think it would be an interesting thing, an interesting exercise to go off and do. But I guess what I'm saying is it's I agree with you Kelvin, yes, the timing information would be super useful. A different display that made that a little more apparent, I think, like what you had in here might be a good view of that, or maybe what is in dprof. Is that what it was called?
I think it's issue 179.
Sorry.
I think too, there's not going to be one universal visualization. Like if you're interested in understanding timing, that might be one thing. If you're interested in understanding profiling information, if you're interested in understanding some sort of correctness issue, you might want to look at things in a different way. So there's definitely a lot of challenges in visualizing large structures like this.
Mm-hmm.
I think of it just as a bag of data to correlate to other data. Like that doesn't really include any information about like this was a set timeout or this was a promise or what it was really. It's just a thing happened. But like in at least APM worlds, like we're going to want to correlate that to, yeah, this was a database request, this query happened, and all that stuff. Like we're going to get that from a separate channel. This is purely just like forming the linkage, just to like identify the causality of things. And like part of that would be like APM is going to capture its own timing information. So I don't think this in itself actually needs timing information. It just needs to exist at the time that the capturing happens.
Yeah, and I think the way that I kind of structured this, this thing is that this code is really kind of hacky at the moment, especially this little file. But where is it? You would have something that would just listen for these events, right? If you were interested in it, right? And then you can associate information with different things when those events are raised, right? I guess would be the intention. I guess the hope would be that would be sufficient for APM vendors to, capture and retain the information that's needed, so that you can provide useful stuff back to the user. It's not clear to me that I guess I would need to think about it a little more deeply about whether or not you would actually need to listen for these events versus just being able to, navigate the graph and, when certain things happen, know what your current execution context is and then associate things with the current execution context, and then go back and walk through that graph to find useful information.
To me, a stream makes more sense than a graph to walk through because it's going to use less memory as a stream. You can get it out of the process faster. Like you can always rebuild the graph from the stream if you need to.
Oh, from a stream. Yes, you can. I think there's applications where so there's a few things with the graph, and that we've sort of been, as we've been talking about some of this internally over the last few weeks, that are maybe a bit of a challenge. One is that there's use cases where you need the graph, right? So you could imagine for example, if you're doing a continuation local storage, you want to be able to traverse this graph, right? If you're doing, you want to know long call stack, you want to be able to traverse this graph. If you're doing, if you're working at a lower level and you want to have some debugger affordances, like we talked about, asynchronous step back, right? How would you do that? Or asynchronous step into, how would you do that? Having the graph poses some problems. I think one of the critical ones is like, well, how do you account for the the collection of these nodes when they're no longer needed? It's one of the things that we've sort of been talking about in terms of implementing stuff if you implement things at the native level, how does that work, right? And that's sort of where some of the use cases that we've been talking about, I think, are going to require some APIs at a native level and are going to require interop with other pieces of native code and are then going to require some some way to clean these things up. But I do think there's cases where you want to have a materialization of the graph, right? And ideally, you want that done for you, right? Like that is, if you need that, I don't want to have to go off and necessarily write that code. I just kind of want to know that it's there and it works, and I don't need to think about memory or things like that.
I'd still kind of prefer that it's like a feature that you have to turn on or something like that. Like even if it is built in, just not store all that automatically. Like another thing to think about is like graph filtering and like simplification. It's like in the context of APM, there's like a limited subset of things we actually care about, like mainly just I/O related things. And so like any asynchrony between those doesn't actually matter. We don't care about each of those having their own separate context, really, as long as we can just like draw the line from this thing eventually came out of this thing. And so, like,
yeah,
you could compact the parts we don't care about somehow.
Yeah, you could certainly construct overlays on top of this that simplify it, right? I think the question is there something that, is there a way that you could do that for, everybody? Like APMs may have a very specific use case for this, and, debug scenarios may have a different use case where they can't make those simplifications. They can't collapse a bunch of nodes into one thing, right? That's, I don't have a good sense of what the right answer there is. I do think that, it's like at a minimum sense, each of these nodes is just, like a number, a few numbers, I think, right? And so I'm not too worried about memory, assuming that, we have an effective way to kind of clean things up, right? And we talked about a few different approaches to that, but yeah.
So I want to point out one thing that I think is kind of interesting in the code where you build the continuations, and this goes back to sort of the filtering. If I don't know if you have that around, Mike.
Yeah.
Where if it's already a continuation, you just pass that along. So in that sense, this construction, if you have like in Node, if you have I/O that the user calls, that then internally calls some async I/O, it's going to maintain that continuation context from the outer level call from the user code into the first node code. So you'll only see that one transition, right? That's sort of the default behavior here. Now you could change this if you were another user and imagine saying, oh, I want to see every link. So the continuations would then start to nest within each other and unwrap.
Yeah, and that was exactly the point. I think one of the first iterations of this
did that unwrapping. And so you would see way more nodes, even in your example, because you'd see all the async that happened internally in console rather than just the one call.
Yeah, and that's exactly that's exactly the intent. And I think some previous iterations of some of this code didn't have this construct, and we would end up with effectively a bunch of those sort of superfluous nodes in the graph, right? And getting back to your point, Stephen, this is in effect, this is in some way collapsing some of this stuff, right? That is, you can have some of these, you can call some of these continuation points, and without this, you would see those things there. So it is, in some sense, simplifying stuff. So yeah, I think the key thing here, this is in this branch here, it's all public. So I encourage you to like take a look at it, tell me what doesn't make sense. Tell me if some things could be done better. If you want to play around with visualization stuff, or you think there's a better way to visualize things, reach out. When I get this complete, I'll merge it back into the master on this thing. But I do feel like we're sort of making some progress here. Not as fast as I would like to be, but I feel like we're making a little progress here. So yeah. Anything else? Anybody have any questions about it?
I shared a thing in the chat that might be useful for people to look at, which is just called a universal monitoring bus. That it's just expressing like both tracing and like metrics reporting just as a stream of messages, and you can like basically subscribe to particular like criteria subsets of messages. As just an idea I was experimenting with, which like that was kind of what I was thinking about with this sort of like large pile of nodes tree thing, trying to have like a way to filter that down.
Yeah, it almost feels like this is overlap or related to the diagnostic channel stuff. Am I reading it wrong?
Somewhat, yeah. It was my experimentation after the diagnostic summit before, just to think about how to achieve that sort of idea. Just having like a universal channel that anyone can just spam whatever data they want into it, and any vendor could just say, I'm only interested in these things.
Like ETW for Windows.
It's not super efficient because it basically just does like an object subset compare for the watching thing. But it would probably make more sense to have like tags or like tag strings or something like that.
Yeah, or ints or something.
Yeah, I just went with the object subset compare thing just to, well, I was trying to like figure out if there's like any particular types of criteria that people might want to filter on. It's like tags, you could just like naively say like, okay, I'm interested in like anything that is HTTP or anything that is MySQL or something like that. But there might be a little more nuance to what parts of that you actually care about. Like,
yeah, I think
you might care about like HTTP upgrades or things like that, whereas another vendor doesn't or something.
Yeah, and I think this is some of the concepts that we were talking about with the diagnostic channel, and basically being able to have some kind of a message bus that people can publish information to, and then listeners can consume it off of. A way to do that efficiently, a way to do that with arbitrary data, and arbitrary consumers and arbitrary producers, and it sounds like there's a lot of overlap with that. It'd be interesting to see if, as we talk about the async context events, if those are the kind of things that we would want to publish across an event bus like this. That's not something that I necessarily thought of, and I don't see why you wouldn't want to do that if such a bus existed, right?
Yeah, that's kind of what I'm doing with here. That like this on its own actually has no context of any like correlation between things really. It's entirely up to the aggregator to achieve that. Like the aggregators can like collect parts of spans in a trace together and can join that into a transaction.
Yeah, this might be a good start for some of the stuff in the diagnostic channel. Thing, issue 180. And like right now, I think it's completely greenfield. Like I don't even think the repo exists. Oh, whoa. Let's not do that. Okay, does anyone have anything else, or?
No, I think I'm good.
Okay.
Stephen, do you mind if we look at that universal monitoring bus repo? You said it was pseudo public.
Yeah, go ahead. Yeah, it's just I have the source available, but I haven't like put any license on it or anything, I don't think. And it's who knows if it's actually useful for anything right now. I make no promises of support necessarily, but it's just sort of testing ground right now.
All right. Well, that's all we have from our side, I think.
There was that?
Nothing more from our side.
Okay. Great. Thanks, everybody. There's no comments on or questions from the YouTube stream. Has anybody been watching that? No? If you could sign in, there should be a link to a notes doc. I scratched a few things down here, but at least put your name so then I can, when I type up the minutes, I'll have accurate attendance. Cool. All right. Bye, everybody.
Bye-bye. Bye-bye.
Bye.
See ya.